Have you ever found yourself humming a song you haven't heard in years? Maybe it's a tune from your childhood, a favorite song from high school, or a melody that instantly takes you back to a special moment in your life. Without even trying, every lyric comes back to you. Every note feels familiar. It's as if your brain has been quietly preserving that memory for decades, waiting for the perfect moment to bring it back. Now think about something much simpler. You're introduced to someone new. They smile, shake your hand, and tell you their name. Just a few minutes later, it's gone. You remember their face. You remember the conversation. You might even remember what they were wearing. But their name seems to have vanished completely. Why does this happen? How can the human brain, one of the most sophisticated organs in the known universe, store thousands of songs, recognize countless faces, and preserve memories from decades ago, yet struggle to remember a single name that was spoken only moments earlier? For many years, scientists believed forgetting names was simply a sign of poor memory or aging. But modern neuroscience has revealed a far more fascinating explanation. The truth is, your brain doesn't treat all information equally. In fact, names and music follow remarkably different pathways through the brain. They are processed by different networks, strengthened in different ways, and stored using entirely different mechanisms. The reason songs stay with us for years isn't because they're easier to remember. It's because your brain was designed to remember them differently. And once you understand how these hidden memory systems work, you'll begin to see why forgetting a name is completely normal, and why certain melodies can remain with you for a lifetime. Today, we'll take a journey deep inside the human brain to uncover the science of memory. We'll explore the remarkable roles of the hippocampus, the auditory cortex, the amygdala, and the intricate network of neurons that shape the memories you keep and the ones you lose. Along the way, you'll discover why music has such extraordinary power over the human mind, why emotions make memories stronger, and most importantly, what neuroscience teaches us about remembering names more effectively. Before we dive deeper, let us know in the comments where you're watching from. We'd love to hear from you, and don't forget to hit that subscribe button so you never miss any of our upcoming videos. Now, let's uncover one of the brain's most fascinating mysteries. At first glance, remembering a person's name and remembering the lyrics to your favorite song might seem like the same kind of memory. After all, both involve recalling information that you've encountered before. But inside the human brain, these two tasks are surprisingly different. To understand why, we first need to understand what memory really is. Contrary to popular belief, memory isn't a single storage box hidden somewhere inside your brain. There isn't one place where every fact, face, or experience is permanently stored. Instead, memory is a vast network of billions of neurons communicating through electrical and chemical signals. Every time you learn something new, tiny connections between these neurons become stronger or weaker, creating pathways that allow information to be stored and retrieved. Think of your brain less like a filing cabinet and more like an enormous city connected by countless highways. Some roads are wide, well-maintained, and traveled every day. Others are narrow, rarely used, and eventually begin to fade. The more often a pathway is used, the stronger it becomes. The less it's used, the more difficult it is to find again. This remarkable ability to change and strengthen its own connections is known as neuroplasticity. It's one of the reasons the human brain can continue learning throughout life. Every conversation you have, every book you read, every place you visit, every song you hear, leaves a physical trace within this intricate network. But not every piece of information receives the same treatment. Your brain is constantly making decisions about what deserves to be remembered and what can safely be forgotten. If it tried to store every sound, every word, and every face you encountered each day, it would quickly become overwhelmed. Instead, it acts as an intelligent filter. Only the information that appears meaningful, emotional, repetitive, or useful is given priority. This filtering process begins almost the moment new information enters your senses. Imagine meeting someone for the first time. Within seconds, your brain processes their facial features, their voice, their clothing, their body language, the environment around you, and dozens of other details simultaneously. It's an astonishing amount of information. Yet among all those details is one small piece of information that often receives the least attention: their name. Unlike a face, a name usually has no visual meaning. Unlike a song, It has no rhythm or melody. Unlike an emotional experience, it carries little personal significance when you first hear it. To your brain, it's simply an unfamiliar sound competing with countless other pieces of information. That makes names surprisingly difficult to encode into long-term memory. Scientists often describe memory as occurring in three major stages. The first is encoding, the process of taking in new information. The second is storage, maintaining that information over time. The third is retrieval, bringing it back when you need it. If any one of these stages is interrupted, remembering becomes much more difficult. In many cases, forgetting a name isn't actually a failure of memory retrieval. The memory may never have been encoded properly in the first place. Perhaps you were distracted. Perhaps you were thinking about what to say next. Perhaps the introduction happened too quickly. Your brain simply didn't mark that name as important enough to store. This is why memory researchers often say that attention is the gateway to memory. If you aren't fully paying attention when information first arrives, your brain has very little chance of remembering it later. But this raises an even bigger question. If names struggle to capture the brain's attention, why do songs seem to do it so effortlessly? Why can a melody heard decades ago suddenly come flooding back with perfect timing, complete lyrics, and vivid emotions? To answer that question, we need to travel deeper into the brain, to a remarkable structure no larger than your thumb. It's called the hippocampus, and it plays one of the most important roles in transforming everyday experiences into lifelong memories. Deep inside your brain, tucked beneath the outer folds of the cerebral cortex, lies a small, curved structure about the size of your thumb. Is this important enough to remember? If the answer is yes, the memory begins a process called memory consolidation. During consolidation, fragile short-term memories are gradually transformed into stable long-term memories by strengthening the connections between neurons. With enough reinforcement, these memories become easier to retrieve, sometimes years or even decades later. If the answer is no, the information slowly fades away. This process is not a flaw in the brain. It's one of its greatest strengths. Forgetting allows the brain to remain efficient, making room for new learning instead of becoming overloaded with unnecessary details. So where do names fit into this system? Imagine meeting someone for the very first time. Their name is often a completely unfamiliar sound. Unlike the word doctor, teacher, or mother, a personal name usually carries very little meaning on its own. It doesn't describe what the person does, what they look like, or how they're connected to you. To the hippocampus, it's simply a new sequence of sounds. Now compare that with a familiar face. A face provides your brain with an enormous amount of visual information. Eye shape, hair color, facial expressions, movement, and countless unique features. Your visual system is highly specialized for recognizing faces, which is why you can often recognize someone instantly, even after many years. This is why you may remember exactly who someone is while struggling to recall what they're called. The face and the name are not processed in the same way. The face benefits from powerful visual recognition systems. The name relies almost entirely on memory encoding. And if that encoding is weak, the name is far more likely to disappear. Attention also plays a critical role. Think back to the last time you were introduced to someone new. Were you fully focused on hearing their name? Or were you already thinking about what to say next? Perhaps you were looking around the room. Maybe there were several conversations happening at once. Or perhaps you were simply nervous. In situations like these, the hippocampus receives less focused attention, making it much harder to create a lasting memory. Psychologists sometimes describe attention as the gateway to memory. Without attention, the hippocampus has very little information to work with. This explains why repeating a person's name shortly after meeting them can dramatically improve your chances of remembering it. Every repetition tells the hippocampus, this information matters. Each repetition strengthens the neural pathways responsible for storing that memory. Sleep also plays a surprisingly important role. While you sleep, especially during deep sleep, the hippocampus helps replay many of the experiences from your day. This replay strengthens important memories and gradually transfers them to other parts of the brain for long-term storage. It's almost as if your brain spends the night organizing and filing away everything you've learned. Without enough quality sleep, this process becomes less effective, making it harder to remember new information the following day. But even the hippocampus cannot fully explain why songs seem so unforgettable. If names depend heavily on this single memory system, why can a melody instantly bring back memories from decades ago? Why can music unlock emotions, places, and experiences with extraordinary accuracy? The answer lies in something unique about music itself. Unlike names, music doesn't rely on just one part of the brain. It activates an entire network of brain regions simultaneously, regions responsible for hearing, movement, emotion, language, and memory. And together, they create one of the strongest memory systems the human brain has ever developed. Imagine hearing the opening notes of a song you haven't listened to in 30 years. Within seconds, something extraordinary happens. Without consciously trying, the melody feels familiar. Then the lyrics begin to surface. Before you realize it, you're singing along almost word for word. Even more remarkable, the song doesn't just bring back its lyrics. It can bring back an entire moment in your life. Perhaps you remember where you were when you first heard it, the people who were with you, the emotions you felt. Even the sights, sounds, and smells of that day can suddenly become vivid again. How is this possible? The answer lies in one of the most fascinating features of the human brain. Unlike a person's name, music is not processed by a single memory system. Instead, it activates an entire network of brain regions at the same time. This is one of the reasons music is so deeply embedded in our memories. When you listen to a song, your auditory cortex is the first to respond. Located in the temporal lobe, this region analyzes the sounds you hear, recognizing pitch, rhythm, melody, harmony, and tone. But the auditory cortex doesn't work alone. Almost immediately, other regions of the brain join the process. The hippocampus begins linking the music to memories. The amygdala connects the music with emotions. The motor cortex may become active, making you tap your foot, clap your hands, or dance almost automatically. The prefrontal cortex helps recognize familiar patterns and predict what note comes next. At the same time, language centers help you remember lyrics. Instead of relying on one pathway through the brain, music travels through many. Think of it like crossing a river. If there's only one bridge and it becomes blocked, reaching the other side becomes difficult. But if there are 10 bridges connecting the same destination, the journey becomes much easier. Music creates multiple pathways for memory retrieval. If one pathway weakens over time, another may still lead you back to the same song. This is one reason songs can remain accessible for decades. Another powerful factor is rhythm. The human brain naturally seeks patterns. From your heartbeat to your breathing, from the changing seasons to the rhythm of walking, your brain constantly searches for predictable sequences. Music is built upon these patterns. Rhythm provides structure. Melody provides direction. Together, they make information easier to organize and retrieve. This is why children often learn the alphabet by singing it. The letters themselves can be difficult to memorize, but once they're placed inside a melody, the brain remembers them far more easily. The same principle explains why many people can still remember commercial jingles from childhood, television theme songs, or songs they learned decades ago in school. The melody acts like a framework that supports the information stored within it. Repetition also plays a crucial role. Think about how many times you've heard your favorite song. Maybe dozens, perhaps hundreds. Some songs have been played so often that your brain has strengthened the neural pathways every single time you listened. Neuroscientists often summarize this process with a simple phrase: neurons that fire together, wire together. Every repeated experience strengthens the communication between groups of neurons. Over time, those neural connections become faster, stronger, and more efficient. Eventually, recalling the song requires almost no conscious effort at all. This is one of the reasons professional musicians can perform complex pieces entirely from memory after years of practice. The repeated activation of the same neural circuits has made those memories exceptionally stable. But repetition alone doesn't explain everything. Many songs you've heard only a few times can still trigger powerful memories years later. Why? Because music does something few other experiences can do. It awakens emotion. A single melody can make you smile. Another may bring tears to your eyes. One song may remind you of your first dance at a wedding. Another may remind you of driving with friends on a warm summer evening. Another may transport you back to your childhood home in an instant. This emotional connection gives music an extraordinary advantage over names. A name is often introduced without emotional context. A song is rarely remembered without one. An emotion has a profound influence on how memories are formed. Researchers have even found that familiar music can help people living with Alzheimer's disease recall memories that seemed lost. In some cases, individuals who struggle to recognize family members are still able to sing songs they learned many decades earlier. While music cannot cure Alzheimer's disease, these observations highlight just how deeply musical memories can become embedded within the brain. So, if music is strengthened by rhythm, repetition, multiple brain regions, and emotion, could we use those same principles to improve our ability to remember names? Modern neuroscience suggests that the answer is yes, and the techniques are far simpler than most people realize. After discovering why songs are so easy to remember, an important question naturally follows. If music can create such powerful memories, can we use the same principles to remember names? The answer, according to neuroscience, is yes. While there is no technique that guarantees you'll remember every name you ever hear, research has shown that the brain responds remarkably well to strategies that make information more meaningful, more visual, and more memorable. The key is understanding one simple truth. Your brain doesn't remember information because you want it to. It remembers information because it considers it important. And the good news is that you can influence that process. The first strategy is paying full attention. It may sound obvious, but attention is the foundation of memory. When someone introduces themselves, many of us are already thinking about what we're going to say next. We're deciding how to respond, wondering if we're making a good first impression, or simply distracted by everything happening around us. As a result, the name is heard, but it isn't truly processed. Psychologists sometimes refer to this as shallow encoding. The information enters your ears, but it never receives enough attention to become a lasting memory. Instead, try something different. The next time you meet someone, pause for a moment and focus entirely on their introduction. Look at their face. Listen carefully to their name. Allow yourself just a few extra seconds before speaking. Those few seconds can make a remarkable difference because they tell your hippocampus. This information matters. The second technique is repetition. Repeating a person's name shortly after hearing it strengthens the neural pathways responsible for storing it. For example, if someone says, "Hi, I'm Sarah," you might naturally reply, "It's nice to meet you, Sarah." Then, a few moments later, "So Sarah, what brings you here today?" Each repetition reinforces the memory without feeling forced or unnatural. You're giving your brain multiple opportunities to encode the information. The third strategy involves one of the brain's greatest strengths, visualization. Remember, names are difficult because they often have no obvious meaning. But your brain excels at remembering pictures. Suppose you meet someone named Rose. Instead of thinking only about the word rose, imagine a bright red rose flower beside her face. If you meet someone named Hunter, picture them walking through a forest. If someone's name is Faith, imagine the word written on a church window. These mental images create additional pathways that make retrieval much easier. The fourth technique is called association. The brain loves connecting new information to something it already knows. Perhaps the person shares a name with a family member. Maybe their name reminds you of a favorite actor, athlete, or musician. The stronger the connection, the stronger the memory becomes. This is because you're attaching new information to an existing neural network instead of asking the brain to create an entirely new one. The fifth strategy borrows directly from the science of music. Add rhythm. Although most people don't realize it, saying a name with natural rhythm or repeating it in a simple pattern can make it easier to remember. Teachers have used this principle for generations. Children learn through songs because rhythm organizes information in a way the brain naturally enjoys. You don't have to sing someone's name aloud. Simply repeating it with a steady rhythm in your mind can strengthen the memory. The sixth strategy is retrieval practice. Many people assume that repeatedly reading information is the best way to remember it. But neuroscience tells us something different. The act of trying to recall information actually strengthens memory more effectively than simply reviewing it. After meeting someone, ask yourself a few minutes later, what was their name? If you can retrieve it successfully, you've strengthened that memory. If you can't, hearing the correct answer again helps reinforce the pathway for next time. Finally, don't underestimate the importance of sleep. As we explored earlier, the hippocampus continues processing memories while you sleep. A good night's rest gives your brain time to organize the information you've gathered throughout the day. This is one reason students often perform better after sleeping between study sessions instead of trying to learn everything at once. Memory isn't built only while you're awake. Some of its most important work happens while you're asleep. Perhaps the most encouraging discovery from modern neuroscience is this. Forgetting a name doesn't mean your memory is failing. It doesn't necessarily mean you're getting older. And it certainly doesn't mean your brain isn't working properly. In many cases, it simply means the memory wasn't encoded strongly enough the first time. The remarkable thing is that your brain can improve. Through attention, repetition, visualization, association, retrieval practice, and quality sleep, you can work with your brain's natural memory systems instead of against them. But there's one final piece of this puzzle. Understanding how memory works doesn't just help us remember names. It also reveals something much deeper about the human brain itself, its extraordinary ability to adapt, learn, and change throughout our lives. We've all experienced it. You meet someone new, exchange a friendly conversation, and moments later, their name slips away. Yet somehow, your brain can instantly recall the lyrics of a song you haven't heard in decades. At first, it may seem like a flaw in your memory. But as we've discovered throughout this documentary, it isn't. Your brain isn't designed to remember every piece of information equally. Instead, it constantly decides what is most valuable to keep. Music has several powerful advantages. It combines rhythm, repetition, emotion, and multiple brain networks working together. These elements create stronger, more durable memories that can last a lifetime. Names, on the other hand, often arrive without emotional meaning, visual context, or repeated exposure. Unless your brain has a reason to treat them as important, they're far less likely to become lasting memories. The encouraging news is that memory isn't fixed. The human brain remains adaptable throughout life, a remarkable ability known as neuroplasticity. Every time you pay closer attention, create a meaningful association, visualize a name, or actively recall what you've learned, you're strengthening the neural pathways that support memory. In other words, remembering names isn't simply a talent that some people are born with. It's a skill that can be developed. The more you understand how your brain works, the better you can work with it instead of against it. And perhaps that's the most fascinating lesson of all. The human brain contains nearly 86 billion neurons, forming trillions of connections that allow you to think, learn, create, solve problems, recognize loved ones, and preserve the moments that define your life. It is one of the most complex structures ever known to science. Yet despite decades of research, we're still uncovering new discoveries about how it works. Every question we answer reveals another mystery waiting to be explored. If you enjoyed this journey into the science of memory, we'd love to hear from you. What song can you still sing from beginning to end, even after all these years? Tell us in the comments below. We'd love to know the songs that have stayed with you through the years. If you found this documentary helpful, please give it a thumbs up and share it with someone who's always saying, "I'm terrible with names." They might be surprised to learn that their brain is working exactly as it should. And if you're passionate about discovering the incredible science behind the human body, subscribe to Anatomy Uncovered and turn on the notification bell so you never miss another documentary. Here, we don't just explain anatomy. We uncover the extraordinary science that shapes every heartbeat, every thought, every breath, and every memory. Finally, if you enjoyed this video, you'll love our next documentary, where we answer another fascinating question about the human body and reveal the science behind one of its greatest mysteries. Until next time, stay curious, keep learning, and keep uncovering the incredible secrets hidden inside the human body. Thank you for watching Anatomy Uncovered.